Well, welcome to this session on connected vehicles and the future of transportation. It is one of my favorite things to talk about. In our session today, we're going to go over 4 things. We're going to talk first about some of the basics about connected vehicles, the terminology that you need to be aware of, some things about automated vehicles. We're going to talk a little bit about the applications, the technologies that technology underpins and supports. We're going to spend just a little time talking about policy issues that you should just be aware of. But most of our time is going to be spent talking about what it means to you. Why should you care? Why is it relevant to you? And what you should be doing right now. Because you see, that's my passion. For so many years, this has been something that was kind of out there in the future, but it isn't. We're going to talk today about what you can and should be doing today to address how connected vehicles and automated vehicles will change your future. So let's just jump right in, talk about what are connected and automated vehicles. We're going to start with connected vehicles. Now, at the most basic level, a connected vehicle is just what it sounds like. It is a vehicle that is wirelessly connected either to another vehicle or to something in the infrastructure. Now, that something in the infrastructure could be a piece of roadside equipment that you might have put there. It could be a cell tower. So the connectivity can happen a couple of different ways. It can happen through a cell connection or through what we'll call DSRC, dedicated short-range communication. So with either one of those will establish that connectivity, again, either between 2 vehicles, between the vehicle and something in the infrastructure. Now, it's very common, as you will hear people talking about connected vehicles, to think of it as DSRC. And that's one of my pet peeves, is that we use this global term and when actually we're talking about DSRC. So I'm going to be very clear with you today about whether or not we're talking about a cell connection or a DSRC connection. They are very different technologies, the applications are different, and the application that would be relevant to you is also different. So remember when you hear that terminology to think, wait, which technology are we talking about? Because it will make a difference to you. Now, some of the things you might hear us throwing around is V2V, vehicle to vehicle, V2I is vehicle to infrastructure, V2X is kind of vehicle and everything else, pedestrians, motorcyclists, bicyclists, whatever. You'll also hear I to V, which is the infrastructure sending out a signal that the vehicle can pick up. So that's the nomenclature that you'll typically hear around the connected vehicles. So let's talk first about cellular connectivity. Cellular connectivity can be established in a couple of ways. It can be established through embedded cellular that the automotive manufacturers build into the car, or it can be established through a phone, through some kind of carried-in device. In either case, both of those options generate geolocated data. And as you'll see, we'll talk more about the data shortly, but the data is very valuable, and that's really what makes all of this go, is that data. So you can get a cellular connection a couple of different ways, again through embedded cellular or through a carry-in device. Now, cell-connected vehicles. This is a hot issue. It is big business, and the automotive manufacturers are dealing with it very aggressively because, again, it is big business. Ford Motor Company was one of the first ones to come out with their Ford Sync product, and it helped them sell more cars. It's very clear that customers, a lot of younger customers in particular, expect and want that cell connectivity. So this is a big business for the automotive industry. There are also proliferation of app developers. I mean, that's easy to see. All you have to do is get on your phone and you can see the number of apps that are out there that are relevant to transportation and that are drawing on that geolocated data. So the automotive manufacturers were smart about it, and we can learn from this. What Ford and GM did last year is they said, you know, all of us are smarter than a few of us. So they opened up the API, the application protocol interface, on their dashboards and said, app developers, come and get it. develop apps, we'll look at them, we'll decide what works in our vehicles, what doesn't, but they harnessed the creativity of app developers in the community to bring that kind of capability into their vehicles. It's under their control, they're watching it, distraction is an issue they're paying attention to, but they're taking advantage of all this creativity. The other thing that happened last year, General Motors announced that in their 2015 model year, so those are the cars that come out later this year, all GM models will come with embedded cellular. Not the high-end ones, all of them. This is moving at a lightning pace. It's a big thing, and we in the public sector need to be able to take advantage of this. Here are some of the things that are going on with cell connectivity. And my worry is you don't hear that much about the capabilities that are out there today. It's happening today. A couple of companies you might be familiar with, Enrix and Here, collect cell-based data from vehicles. They resell it to businesses and to public agencies. And perhaps some of you are in public agencies that are using this kind of data. And we'll talk more about that. I'm going to skip over here to commercial vehicles. DriveWise is one particular company that's using cell connectivity to do clearance and weigh station checks through cell connectivity. Transit, there are many transit applications, and we'll talk about why that is. NextBus is just one that uses cell connectivity to provide real-time transit arrival information. Now let's talk about Waze. Waze is a crowd-based, crowd-sourced application available on your phone. I don't know how many of you might be Wazers. I'm a Wazer. So if you get on Waze, which I recommend that everyone do, you will see the value of crowd-sourced data. Through Waze, you can get real-time traffic information, incident information, work zone information, a vehicle that's parked on the side of the road, where the police are, which direction the police are facing. All of it's on Waze. So I would challenge you to get on Waze, look at what you've got, and ask yourself, who has more data, them or us? Now, Waze has about over 50 million subscribers. They were bought last year by Google for $1 billion. Do you think Google might believe that there's some value in crowdsourced traffic data? This is a huge thing, all being done today with cell connectivity. All right, now we're going to shift gears. Now we're going to talk about dedicated short-range communication, DSRC. This is a different technology. This is a Wi-Fi based technology. So if you think of the Wi-Fi router that's in your home, that Wi-Fi router has been modified to work in the mobile environment on a car. So it is a very short-range communication, and it's very fast, and communicates data off the vehicle into space. So DSRC, some of the characteristics about DSRC. First of all, as I mentioned, it's very low latency, making it very fast. It is uniquely suited to imminent safety crash situations because of its speed. If you think about cell connectivity, cellular is a point-to-point communication. DSRC is a point-to-many. It's a broadcast communication, and that's one of the characteristics that makes it so fast. Now, DSRC is the subject of a lot of tests. We'll talk some more about that, about the safety benefits. There was a big thing that happened this past year. Not this past year, it was in February of this year. NHTSA, the National Highway Traffic Safety Administration, the DOT administration that regulates safety in automobiles. These are the ones who bring us seat belts and airbags and anti-lock brakes and those sorts of things. They've been studying it, and they made an announcement in February that they intend to pursue regulatory action for DSRC. All right, so that means that they are going to start the process that would require ultimately that automotive manufacturers must include DSRC in their vehicles. And I'll tell you more about that time frame. This is a quote from NHTSA when the press release was made in February. V2V technology can address a large majority of crashes involving 2 or more motor vehicles. To be clear, NHTSA's interest is in safety. That is their legislative mandate. Their role is safety. So many of you all of you are in public agencies, so you know we talk in code, right? So let me decode this for you. So V2V technology can address, doesn't reduce, doesn't eliminate, doesn't say any of that. It says can address a large majority, didn't give a specific number because we don't know yet, a large majority of crashes involving 2 or more vehicles. So the most important thing for you to take away from that is it's not all crashes. This technology doesn't address everything. It's vehicle-to-vehicle related crashes. So single vehicle run off the road, it will not address that unless you do a V2I application. Okay? So this is the quote from NHTSA. So this was a big deal. It is a big deal, and it will be driving a lot of innovation in that marketplace. So let me just talk a little bit about how the technology works. So DSRC, as I said, is a Wi-Fi transmitter and receiver. So it both receives and transmits. So it takes data off the vehicle and it transmits it into the atmosphere 360 degrees around the vehicle 10 times a second. So data off the vehicle, pumped into the air 10 times a second. So a similarly equipped vehicle that has a DSRC receiver can pick up that data from the adjacent vehicle. There are algorithms that are on the vehicle, so they're able to pick up that data, the algorithms process it, and are able to tell you, the driver, if you are about to be in an imminent crash situation. At this point, it's a warning to the driver. It's not control for the driver, okay? So that's how DSRC works. So there's a lot of data flying around, a lot of algorithms, and that's what's being tested. All right, so we talked a little bit about this. The thing that makes this possible is that years ago, the FCC allocated spectrum specifically for this use. Now, you are probably well aware the high value that's placed on spectrum. So we've been working with this spectrum now for years, doing the research to get to this point. So about 2 years ago, the rest of the industry woke up and said, wait a minute, look at that spectrum that they have that they're just testing. And so now there has been a push in private industry to get access to that spectrum. This is a big issue. You don't need to do anything about it necessarily, but just know that there is a big issue out there. It's being worked. It's the subject of a proposed rulemaking to share that spectrum, and there's a lot of concern about the safety implications if the spectrum is shared. So that's an active issue that's going on right now. So the other thing that you need to be aware of, and I'll talk a little bit more about this, as I mentioned with DSRC, the way it works is there's data that's taken off the vehicle, pumped out into the air. It's very important to know what specific data is being distributed. It's called the basic safety message. This is very important to you because depending on the type of data that's transmitted, it either helps you or doesn't do you any good. Because if it's not the data that you need for your applications, then it's not helpful. They're transmitting right now the data that is needed to power these V2V safety applications, and I'll show you a list of those in a minute. So that's another thing you will need to pay attention to, and I'll mention it again. Again, the other thing, both vehicles have to be equipped. It doesn't work if your vehicle is equipped and nobody else's. Then you have nobody to receive information from. So both vehicles have to be equipped. So that has a timing implication, although I will say that with NHTSA making a decision about its intention to start a regulatory action, we believe that it will catalyze an aftermarket industry that will figure out ways to bring this technology into the vehicle other than having to have it built into the vehicle. But I'll talk a little bit more about that timing in a few minutes. A common misconception that we hear a lot, people think that V2V is going to require infrastructure from you all in the public agency. It does not. It does not. NHTSA can proceed with V2V implementation without any infrastructure being deployed by state or local governments. There is infrastructure that will be needed, probably cell-based for the security system, and I'll mention that again shortly. So I mentioned the tests. So if you are NHTSA and you are going to make a decision about whether or not to regulate this technology into the vehicle fleet, you need to know if it actually works, right? It's a big deal to tell all these automakers to change how they're manufacturing their cars. So they have to do that based on data. So to do that, they did a big test in Ann Arbor. Perhaps you heard about it, the Safety Pilot Project. The first phase of that is now complete. They instrumented 64 vehicles. They instrumented 3,000 other vehicles that just transmitted data so that the 64 could both receive and send. They collected data on these 6 safety applications. So these are the 6 applications that were tested in Ann Arbor last year. The data from this test was used to evaluate and assess whether or not NHTSA would choose to move forward. And they apparently got good data, and they chose to move forward with the regulatory action. The safety pilot model deployment in Ann Arbor, Michigan has now been extended. So it's going to continue in place. They're going to test some V2I applications now, that vehicle to pedestrian, motorcycle, and some other applications, taking advantage of that installed base of technology in all those vehicles that are equipped. So it's very good news that this test is going to continue. So NHTSA, again, in February, made the announcement about their intention to pursue regulation. They will be releasing a report with more of the technical details in it. As of the time I'm standing here, that report has not yet been released. We're all waiting for that because it's going to cover a lot of the technical details that we all are interested in, about some of the privacy issues, about the specific pieces of data, about the security system that I'll mention in just a few minutes. And again, this will be an important document when we get that document out. So let's talk about timing. This is important. Now remember, just a minute ago we talked about cell connectivity being here today. So what does DSRC connectivity look like in terms of timing? So NHTSA announced in February that they're going to start the regulatory process. This is not something that's fast, nor would you expect it to be fast. You would like for this to be a well thought out, considered thing. It will likely take a couple of years for NHTSA to get through the complete regulatory process, because they put out a draft regulation and people can comment, and they could do that a couple of times. We don't know what their intention is at this point. Typically, in a NHTSA regulatory action, they will take some time to get it out, to get it written correctly. Then it will have a phase-in period. It's very likely that this one too will have a multi-year phase-in period. So we could be looking at 3 to 8 years before an automotive manufacturer would be required to have the technology on their vehicle. So now think about how much technology has changed in the last 3 to 8 years. So we've got a lot of ground to cover in here. Now then, that pertains only to new vehicles. So then after that, then you have fleet turnover. To turn over the entire fleet takes between 20 and 30 years. Now again, as I mentioned, we believe that if NHTSA goes this far, that you will see a market develop for aftermarket devices that will bring the technology into the vehicle. So we don't think it would take that long, but anyway, you're going to see something measured in quite a few years before you see this really being a big thing that's going to impact safety in a big way. So you need to keep that in mind, and that's why I urge you to really jump into the middle of this and take advantage of both DSRC and cell connectivity. Okay, that's connected vehicles. We talked about connected vehicles with cell connection, connected vehicles with DSRC connection. Now let's shift gears and talk about automated vehicles. So Google, this is the Google car. Google has gotten a ton of press around the Google car. Now to their credit, Google's not an automotive manufacturer. To their credit, they have cataloged a conversation with the public and with the automotive industry. They have catalyzed the imagination of the public around automated vehicles. Now, in the automotive industry would be very quick to point out that they were already working on this. They were just doing it not quite so publicly. But now everyone's working on it. Not too long ago, I guess it was last year, NHTSA released a policy document about automated vehicles because you were seeing so much churn out there. They talked about their research plan around automated vehicles. They're very heavily into this space. This document speaks to states who want to rush to legalize automated vehicles. And that's actually what the intent of this document was for, was to say, wait a minute, not so fast. Let's think this through before you do it. The other thing that the document did that got a lot of traction is it identified levels of automation. So just so you know, you don't need to, there's no quiz on the levels of automation, but just so that you understand the technology that you might hear or the terminology that you might hear. Level 0 is the cars that you would have driven a long time ago, the ill-equipped, or not ill-equipped, just not sophisticated vehicles. Level 1 are vehicles that have one type of system that has automation in it. Automated cruise control, for example, adaptive cruise control. Level 2, vehicles that have more than one, a couple of automated systems in them. When you get to level 3, there is some self-driving capability under limited roadway conditions. Level 4 is full automation. So the question becomes, when do we get to each one of these? Good question. Here's where we are today with some of this technology. Clearly level 2 and level 1 is on the market, level 2 is coming into market, level 3, there's a lot of people researching that. Level 4, this is the one that Google says they're going to have in 5 years. Most people think that's a bit of an exaggeration and that it's probably going to take more like 20 years to get to full self-driving capability in all situations. What most people believe will happen is that you'll see self-driving capability happen on relatively simple roadways first. Important for you to think about. Freeways, for example, are the roadways that have the least interacting parts to them. That's likely to be where you would see automated vehicles happen first. The last to come, likely to be city driving. I mean, just think about all of the conflict points, Fluffy and Rover and soccer balls and all kinds of things that can happen in a city environment. Those are likely to be the final environments that you would see happen. So automated vehicles, again, big money involved here, a lot of interest, a lot of research going on. It's moving very fast. I want to just briefly touch on some policy issues. All of these issues are being worked at the national level, but you ought to be aware of them. And if you think about it very hard, these are questions that will probably come up, and you might hear perhaps people in your organization who say, oh, well, but what about that privacy issue, right? So let's talk about privacy. It comes up all the time with connected and automated vehicles. Today, with cell-connected vehicles and the apps that are on your phone, when you sign up for the app, you agree to the terms. It's what's called an opt-in service. So you have opted in to sharing your data, sharing your information, sharing your location. You get those little pop-ups on your screen that says, it's, can I enable your location service? So when you do that, you have agreed to share your data for that app. So that's what happens with cellular today. With DSRC, if it's required, it's not opt-in. But the way that it works with DSRC, if you think about how the vehicles communicate for safety purposes, all we want to do is to make sure that this vehicle doesn't crash into that vehicle. You don't need to know the VIN number to keep them from crashing. You don't need to know who's driving it to keep it from crashing. The system is literally designed so that the data that is shared between the vehicles is anonymous. It's location, it's speed, it's yaw, it's acceleration. Those are the kinds of data that are shared between the vehicles, nothing personal. However, We're going to talk about the security network in a minute. There is some personal information that is very likely that will have to be shared with the security system. So that's how privacy is being managed right now with DSRC connected vehicles. Data ownership. Personally, I think this is going to be a big one. You're beginning to see, as more and more vehicles become equipped using cell technology, a lot of data is being shared from the vehicle. You're now seeing some concern expressed by congressional members about, well, whose data is it? I think this is going to be an important policy issue, not resolved today, being worked, but this really is a big one. So if the vehicles are sharing the data, is that your data? Do you get to choose? Probably not. That's a big issue. US DOT authority, just briefly touch on this. NHTSA is very clear on their authority. They have authority to regulate safety in the vehicles. They have authority to require a security system. They have an authority to regulate the aftermarket technology that comes into the vehicle. That's a big deal. FHWA, the one that you all deal with more frequently, FHWA does not have that kind of authority. They do not have the authority to require you to install DSRC-based equipment in your roadside. You choose that. Now, having said that, you'll see FHWA plans to come out with some policy guidance in 2015 that would advise you on their recommendation on the kinds of actions that you should take, but it is not a requirement. Driver distraction has been a big thing. Secretary LaHood, when he was here, that was his big signature issue. Secretary Fox appears to be taking up the same topic. The automotive industry, the aftermarket industry are very cognizant of this. NHTSA has put out some driver distraction guidelines to guide their development. So this is something that's being attended to very, very closely. I've already mentioned the spectrum issue about the spectrum around DSRC. Security network. I've alluded to this a couple of times. And I mention it now because you need to be aware of this. It impacts you. So this is the deal. Just imagine you're a car. And if you imagine that you're a car and you are a Ford, and you're a Ford manufacturer, and you know how you've manufactured your car, you know the quality control, you know all your suppliers, you know how you've manufactured your Ford. And now you've got your Ford and you're out driving around. And you've got DSRC and you're sending out your data. But now you're picking up data from let's say a Kia. You don't know anything about how that Kia was manufactured. You don't know anything about their quality control. You don't know much about their supply chain, and they're sending out data as well. So now you are in a position as your Ford of receiving the Kia data, bringing it into your vehicle, and giving your customer a crash warning based on that data. Might make you feel a little nervous. Never been anything done like this before. This is what makes this such a watershed technology. So in order for the vehicle manufacturers to trust each other's messages, there has to be a security network that validates that you are you, that that car is really a car, and that they can trust the message that they're receiving. They're going to do that through what's called a public key infrastructure, which means that every vehicle are issued a set of electronic certificates. And as long as your certificate is valid, meaning everything's working fine with your car, then everyone else can hear your message. If something goes wrong with your certificate, the security network, which is cell-based, revokes the certificate so that no one else can hear your message. So that security network is the most complicated part of this system. It has to be resolved. It's not resolved today, and it has to be resolved. And by the way, someone has to run it. Someone has to manage it, someone has to be in control of the processes and the procedures, and it has to be financially self-sustaining. This is a tough job. This is a very simplistic depiction. So just to be clear, DSRC would be sharing the data at low latency between the vehicles. But a cell connectivity is very likely the way that the certificates would be delivered and managed by some entity in the middle. Here's why you care. If you choose to do vehicle to infrastructure, say with a traffic signal, the same thing applies. Those cars have to know if they can trust your traffic signal. You too would have to be part of this trusted network. You would have to participate in the security network. We don't know if it would be a cost to it, what the procedures are, but there will be something that you will have to be involved in for you to be able to put a DSRC-equipped traffic signal, for example, on the roadside. So you just need to pay attention to how this evolves. Okay, now let's shift gears. Let's talk more about what's in this for you and what you can do now and what I believe you should be doing now. As you probably can tell, data is the big thing. We're talking about boatloads of data here. Imagine 10 times a second packets of data coming from every vehicle. There is a ton of data here. That data can be useful. It can help you with management and operations issues, weather issues, gives you new capabilities that you never had before, again, if you have the right data. All right, so let's talk about this. Here's how I've structured our conversation. If you think about today, not in the future, today, there are several functions that you perform. One is that today, you capture data. Loop detectors, various kinds of technologies, cameras. You're collecting transportation traffic data today. Some of you may be buying data today. You can also be a participant in this ecosystem because it's happening today with cell connectivity. And then you're also all providing traveler information. I suspect most everyone has a 511 system. Probably most of you are using social media, which is great. So we're going to talk about these 4 areas and what this connected vehicle revolution will do in those 4 areas. This is the timing. So just to give you a sense of scale, I'm trying to hammer home this point that on one hand you've got cell technologies happening now, DSRC coming, but still several years away. But within your planning horizon, within today's planning horizon. So this is relevant to you today. So if you look at capturing data, you can do it right now with cellular technology today. Not so much with DSRC yet, still in research, finalizing the research. Procuring data, can do that today. It's coming with DSRC, not there yet. To be able to participate, you can do that today with cellular, coming with DSRC. The big difference is, cell connectivity can enable mobility applications, environmental applications, weather applications today. DSRC is specifically, uniquely suited to imminent crash situations. Cell technology cannot do that. Not fast enough, at least with today's cell technology. So there's a very clear difference in the applications between the 2 technologies. There's a clear difference in the timing of the 2 technologies. Okay. So let's look at this. What you can do today. So much of this is about the data. The first thing that if I were in your shoes, I would be assessing my data, assessing what your current data needs are, assessing how you're currently collecting your data, and then assessing what information you're deriving from the data. Right? So the data is just the start. The information is what's valuable. And the reason that I think it's important to make that distinction is because some of the types of individual data are very likely to change. It's not going to be like loop detector data. This is different kinds of data. But can you get the information you need out of a different kind of data? Good question. The answer may be yes, it may be no. But to assess what your data needs are is an important first step. Where do you get it? Is it centralized? Is it distributed? Can you access it easily? Can you not? And to understand that data, that's an important piece of it. And then today you're capturing data. Great, that's good. I predict that's going to change a lot. And even today, there are ways to use cell technology to capture data. Perhaps some of you are using Bluetooth. This is a very early V2I application. It's using the cell connectivity off the vehicle to sense its location. And this is a way today that you can capture cell-based data for your use. Procuring data. So again, we have multiple companies. There are 2 on this slide here. There are multiple companies out there that capture cell-based data, they process it, they clean it, and they resell it. Now, I would mention to you the FHWA data set, and there is a typo on this slide. It is the National Performance Management Research Data Set. Clever name. The NPMRDS. If you are not already taking advantage of this, I would highly recommend that you do. So what FHWA has done is they've gone and they actually have contracted with HERE, and they have collected this data and it's available to you at no cost. So this is a very easy way for, if you're not already using some of this cell-based data set, it's a very easy way for you to get started with it. What I predict is that you will also begin to understand that you also need data analytics. And this is something that you're going to need, you're just going to need it in this world of big data. There are many companies that provide data analytics services. So my recommendation to you is that you go get the FHWA data set, then you start talking to those companies that provide data analytics services, because the data is only so much use to you until you can make information out of it. And there's many people who'd be happy to help you with that. Now obviously you all are in public agencies. There are considerations that we as public servants must take into account as you make these kinds of investment decisions. Does this meet your needs? Is this a wise investment? In the case of this kind of data, some states have discovered that they, for a less amount of money, can get a much broader coverage area than they could ever get through our more traditional methods of collecting data. I predict that the procurement of data will become something that's very common in a very short period of time. This will be, I think, your primary way of getting your data. Be a participant. This is also one of my soapbox issues. It's all about the data. Think about what General Motors and Ford did. They said all of us are smarter than a few of us. And they harnessed the energy of app developers out there in the community. You could do the same thing. You have data. You have weather data, you have work zone data, you have traffic signal data. There are app developers out there that are working with cities right now who are releasing their traffic signal timing data, and they're creating apps that are providing services to travelers today. If you were to release some of your data and make it available under whatever constraints that you want, and I don't think you can sell it, but if you were to release it, you would have app developers that would be there to work with you. There are some states that have done app competitions, work with the universities to have app competitions, to develop some creative apps. It's all about the data. This is a way where you can begin to be a participant in this freight train of technology that's coming our way. It's right here. And I feel like that if you can participate early, then you begin to understand what your role might be and be able to be a smart participant in working with these companies and organizations. So I do recommend that you think about that. Now, again, DSRC, it is coming. I recommend that you get on board. I think you ought to be working with Cellular right now. I think you ought to be thinking about it really hard right now. DSRC, I think it's time. Think about it. You have a 20-year transportation plan. You have investments that you're going to be making that have lifespans of 10, 20, 30, 40, 50 years. What's transportation going to be like in 50 years? Now is the time to be thinking about how you take advantage of this and that you are a player. So today, I don't necessarily recommend that you go out and install a bunch of DSRC equipment. If you want to be a real leader, there are DSRC test beds. There's an affiliated test bed program run by the USDOT. We can provide more information about that. There's a pooled fund study that's managed by the Virginia DOT that you can join and be a participant in. It's a great way to be involved. You can also start looking at what would make sense for you. Look at the projects that are already programmed. Do you have traffic signal system upgrades already programmed in the coming years that could be included and retrofitted for DSRC as well? And cellular. I think that's also smart. Most of the technology companies are looking at both options. They're building equipment for both options. Controller manufacturers can do that. They're on board, they know this is coming, they've been in the mix. Look at them. Can you add just a little bit of budget to give you some flexibility to be able to accommodate this technology within this time horizon? Study where might DSRC be appropriate for you. Locations that might make sense are high crash intersections. Might make a lot of sense for you. Where are those? Study those. Do you have corridors where you need a lot of intense data? Maybe an evacuation. Where are those? Maybe you have some difficult geometrics, because you can do V to I as, say, a horizontal curve, and you transmit the geometrics of the curve. Now, to be clear, the automotive manufacturers have to program the vehicle so they can receive it and do the algorithms, but if the data is there, they've indicated they will do that. I think you can study where DSRC makes sense for you so that the minute it's ready, you're ready, and you're not caught flat-footed trying to catch up. Traveler information. People have traveler information systems, 511, that's great. Social media, really great. However, might this be an area that's changing? 511, it's an excellent thing. Do not get me wrong. People are changing the way they get information. They're changing the way they consume information. Get on Waze and see how you might get information differently. It's not a bad thing, but you need to be aware of it as you position your 511 system for the future, as you upgrade or change your 511 system for the future. You need to be doing that completely aware of how this world is changing at light speed. Now, one thing that we in the public agencies, we have a unique role. You have a unique role. You will always have that role of providing the official information. You will have the role of providing evacuation routes. You will be the go-to people for that real official information. So that's an important role that you don't get to give up. The other role that public agencies serve very frequently is that we're the social justice place. Just because 80% of people have access to smartphones doesn't mean that we get to unplug and go home and not have 511 anymore. And that is an important role. It's a very important role to make sure that there is some equity in the transportation world for people who might not have access to some of the high-end toys. So that's another piece to keep in mind as you think about the future of your 511 system. All right, so that's today. That's today. But now let's take just a moment and fast forward just a little bit. We're going to zoom out 5 to 10 years, right? So zoom. 5 to 10 years from now. Here's where we are. Vehicles connected with cellular technology will be pervasive. GM's rolling them all out this year on all their cars. Everyone's going to follow. It's big business. So in 5 to 10 years, you're going to have a huge base of vehicles with embedded cellular. Capabilities on the smartphones will continue to grow. Crowdsourced data continues to grow. There's just more and more of it. It becomes better and better just with the increased amount of data. DSRC equipped vehicles, if all goes well with NHTSA, in the 5 to 10 year window, you will see the very first DSRC equipped vehicles rolling off the assembly line. So you will have some capability out there for vehicles transmitting and receiving data. Automated vehicles, that one's kind of anyone's guess. You know, if you talk to Google, they're going to say they've got the vehicles out there. Clearly, what is completely clear is you will have increasing levels of automation coming in that time period. Whether we're at full automation, probably not, is my guess. Level 3 could very well be. Level 3, if you remember, was self-driving capability on some roadways. Think about that. Now overlay your transportation plan for 5 and 10 years. It might make you want to think about that a little bit. All right, so let's see what your world might look like. If you're capturing data 5 to 10 years from now, I think there's still a role. I think there's still a role for unique data. Now, I live in Maryland. In Maryland, we have the Chesapeake Bay Bridge. There's unique data needs around the Chesapeake Bay Bridge. It's a high bridge. Wind data is not something that we're collecting off of the vehicles. So there's going to be need for specific data that you're still going to have in 5 to 10 years. But because today you've studied your data needs, you're going to have a good idea of what that is. So you're still going to be in the data capture business and be in assessing which ones make the most sense for you. I predict in 5 to 10 years you're going to be procuring a lot more data. Again, just think about how much it will have exploded between now and then. The capabilities that you will have for buying this data cheaper than you could ever go and capture it all will far outstrip any of the other concerns. I think you will be in the business of buying more and more data in 5 to 10 years. So if you're not already doing that, now is a very good time to get familiar with what that's like. That's why, again, that FHWA data set is such an asset to you. You can start now, low barrier to entry, get your feet wet, get some data analytics going, and begin to be ready to take advantage of this when it's going to be full-blown. Travel information, 5 to 10 years from now, wow, who will have a landline? I mean, really, there's going to be so much going on through the phone and through wireless connection. I think there will still be a role for your 511 type systems. Clearly will be a role for social media. People will be getting a lot of information through Twitter, Facebook, Pinterest. These are powerful communication tools. So this will be a very different world in just 5 to 10 years from now. So it's time to think about that and how to evolve into that world from where we are today. And again, to be a participant. Same thing. If you've gotten your feet wet with sharing data, then you will be well into this ecosystem. In 5 to 10 years, we will see established ecosystems. Today, what we see are some things that are trying to sort themselves out. The automotive industry, app developers, supply chain, they don't quite have it figured out yet on how that supply chain is going to work. 5 to 10 years from now, they will. The question for the public agencies is, are you in it? Or have you been left behind? You can participate now and try to get what you need out of it, or you can wait and you'll get what they give you. Make no mistake, public agencies are the small potatoes here. These are billion-dollar industries that we're talking about, consumer-driven industry. For public agencies to be a player, we need to use the data that you have because they are interested in it to make yourselves relevant and to have a little bit of negotiating room. And again, to be a participant and watch what's going on with NHTSA, to decide if and how you want to participate with DSRC. So now here's the window that the automotive industry is very interested in for you all. They have cars coming off the assembly line that are DSRC equipped. The chances are that they will rarely, literally, bump into another similarly equipped car so that that technology can be taken advantage of. So you're putting on some technology onto the vehicle that for you, the owner, you really don't get a lot of benefit out of it. So the automotive industry is very interested in you having equipped some of your traffic signals, some of your high crash locations with V2I technology where you can take the data off the traffic signal, phase, and timing, SPAT data. So it takes the SPAT data off the traffic signal and similarly broadcast it on DSRC so that the vehicles pick up that signal and they can provide that same kind of warning to the driver that they are about to have a red light and they need to stop. So it's a powerful application. Your traffic signals have to be equipped. Now think about how long it might take you to get that kind of project through your system. It probably fits within this time frame that we're talking about. If you start planning now, assessing where are the locations that make the most sense for you, where are the corridors that make the most sense. So keep in mind, if you install a DSRC transmitter on your traffic signal, it can also be a receiver. So as those vehicles that are equipped are running under your intersections, you can capture the data that they're transmitting. That's why intersections that are high crash locations are probably targets for you. Corridors where you need intensive data, probably a target for you. Again, curves where you can give them information. Other data that you have are bridge heights. Trucking industry, there would be apps developed if they had information about your bridge heights. But it's in this 5 to 10-year window, that you have a unique opportunity to position yourself as having an early winner application for DSRC. It's a safety application that can also give you some data for operations. Automated vehicles, 5 to 10 years. Hard to know. However, I think that where you might see this happening again would be rural freeways, areas where you have limited interaction. Now there are things that you can do to make this work better. Some of the technologies on automated vehicles work by reading signs and markings. So it helps if there are signs and markings. The more legible the markings are, the easier it is for the vehicles to guide themselves. Some of this technology, interestingly, is moving faster in Europe. They say they can read the signs better. It's something about the shape of the signs. Most of those are round. I don't quite understand that. But to the extent to which that you can make it easy for the automated vehicles to work on your roadways, then that's an enabler for those companies. There has been little conversation about this with the automotive manufacturers. I believe it's probably because that they would just as soon be in control themselves and not have to depend on something coming from the public sector. But you can help this work in your areas because it is coming. There's no question about that. It's just, do you help it work well or do you not? So here's your to-do list from me. So if I were in your shoes, here's what I would be doing right now. Again, I would be assessing your data and information needs. What are you getting right now? How are you using it? Where is it located? Can you access it easily? Can you share it easily? I would be looking at procurement options for data. I'd be using that FHWA data set. I'd be talking to data analytics providers. I would be looking to see what part of your data needs that type of data will fulfill. It's probably not all of it, but it could be a very important and increasingly important part of your data picture. Can you be an open data provider? Can you be a participant? Now, I appreciate that's a sticky question, and I understand that in public agencies there are possibly liability issues and there are some concerns. There are places that are doing it. There are cities that are releasing, say, for example, traffic signal timing data to app developers. It is possible to do it. You have to think about what's in the best interest of the people who live in your state and your customers. Can you give them something of value quicker by sharing that data rather than holding on to it? And that's our tendency, because that's what we do. It's what we've always done. Can you begin to flip that mindset and start thinking about being an open data provider? Study DSRC applications. There's an AASHTO footprint study that's available on the SSOM website that has looked extensively at DSRC applications. It mentions cellular applications, but it goes into a lot of depth around DSRC. It's a great resource. It's a very good document, so I commend that to you. Take that information, study where DSRC might be applicable in your state, particularly in those early years where you all have an opportunity to provide some safety benefits early on. And mostly be a part of the game. Again, if you want to be a leader in this area, you can become an affiliated testbed. You can join the pool fund study that's led by Virginia DOT. The U.S. Department of Transportation is going to do connected vehicle pilots. They just recently put out a request for information, so they'll be releasing connected vehicle pilots probably later in 2015, I believe. So that's another opportunity to take advantage of that, where they'll be providing funding for connected vehicle testing. You'll need to be ready. You won't be able to just get ready to go immediately. So the more that you're doing now to prepare yourself, the more likely you are to be able to win one of those grants. Some things to watch for. So again, we know what NHTSA's decision is. They intend to pursue a regulatory action. We need to watch and see what's actually in the detailed report. The things that are of interest to you, two big ones. What are the specific data elements that will be transmitted by the vehicle? And so just a heads up on that. NHTSA probably can only require the data elements to be transmitted that they need for those safety applications, because that's the extent of their legal authority. You need different data for mobility applications. You need different data for weather applications. If you're not there advocating for those other data elements, there is a big limitation on what this will do for you. A lot of things you'll hear in the hype, and I feel like that there is some overhype right now. You'll hear all the hype about how you're going to have all these mobility applications, all this weather information, environmental applications. That's not true if we don't get the data off the vehicle. So that needs to be paid close attention to. The security network. How's that going to work? What's it going to cost you, if anything, to be part of it? What are the rules and the procedures that you would have to abide by? You need to know that, to know how that's going to impact you. I mentioned the AASHTO footprint study, excellent document. Take a look at that. Lots of good material there. They'll save you a lot of time. They've done some excellent work on your behalf, so take advantage of that document. I mentioned early on, 2015, FHWA intends to release a policy guidance document saying to state DOTs what FHWA recommends that you do and how you do it around DSRC implementation. And then also just pay attention to the continued evolution of automated vehicles. You'll see it. You'll see that. It'll be in the news. You'll see the vehicles come to market. You'll see the features being advertised. But pay attention to it and think about, what does this mean to me within my planning horizon? The world of transportation as we know it today is going to completely transform itself. I believe we're going to go from transportation being defined as a car that we buy as to a service that we subscribe to within the planning horizon that you have today. It's revolutionizing transportation. So just to quickly summarize, we talked about the basics of what cell-connected vehicles are, DSRC-connected vehicles, automated vehicles, and the capabilities that they have. a little bit on policy issues, and then you have your to-do list on what you can be doing today to take advantage of this opportunity, because it is today. Thank you all so much for being part of this session.